Imagine a planet forged in the sun's fierce crucible, its cratered skin scorched by stellar fire, yet cradling icy secrets in shadowed hollows and pulsing with a magnetic heartbeat that defies its tiny stature. Picture its charcoal plains glowing, under a sun 7 times brighter than Earth's, a world of extremes whispering tales of cosmic resilience. Step into the orbit of Mercury, where fire meets ice, and mystery beckons from the solar system's fiery edge. Join me on a blazing journey to the first planet of our solar system, Mercury, the smallest planet, a metallic jewel dancing closer to the sun than any other, its fleeting appearances at dawn and dusk captivating stargazers for millennia. From ancient Sumerian scribes to modern probes piercing its orbit, Mercury has lured humanity with its elusive charm. Picture a rocky orb, smaller than some moons, its pocked surface a tapestry of ancient scars, yet alive with a molten core that hums beneath a starlit void. Imagine its searing deserts and frozen poles, a paradox of fire and ice that challenges everything we know about planetary survival. In this video, we'll wander its searing plains, explore its ghostly exosphere, and uncover clues to its violent youth. Together, we'll chase its swift orbit, decode its volcanic past, and dream of future missions to unravel its cosmic riddles, a journey that sparks wonder about our place in the stars. Whether you're a dreamer or a scientist, Mercury's story will ignite your curiosity. Get ready for a world of extremes, resilience, and wonder. Picture Mercury, a small charcoal grey world speckled with creams and beiges, like a cosmic canvas etched by eons, glowing faintly under a sun 7 times brighter than Earth's. Barely larger than our moon, it's a dense metallic pebble, 4 times smaller than Earth, smaller than Jupiter's Ganymede or Saturn's Titan, yet denser than both, its iron heart squeezing more mass into a tighter sphere. If Earth were a basketball, Mercury would be a grapefruit, but heavier than you'd expect, with 70% metal and 30% rock, making it the second densest planet after Earth. Its iron core, nearly 85% of its diameter, makes it a heavyweight in a feather-light frame, its thin silicate crust leaving it naked to the sun's glare. Unlike Venus's cloudy veil or Mars's dusty shroud, this scorched sentinel was forged 4.6 billion years ago in the solar system's fiery crucible, a molten droplet born from a swirling cloud of dust and gas that collapsed, spinning faster as it shrank, like a cosmic potter's wheel. Some believe a massive impact stripped away its outer layers, leaving a metal-rich core, a scar from the solar system's chaotic youth. Mercury's surface, a rugged mosaic of craters and smooth lava plains, mirrors the moon's, scarred by ancient bombardments yet polished by stellar fire. So close to the sun that it races around in just 88 days, its tight orbit bathes it in heat, while its shadowed poles cradle icy secrets in eternal darkness. With no moons or rings, Mercury stands alone, a solitary warrior at the solar system's edge. Ancient eyes tracked its swift dance across twilight skies. Sumerians in 3000 BCE called it Nabu, their scribe god, and Egyptians named it Thoth, the knowledge-bearer, for its elusive gleam. Greeks dubbed it Hermes, the fleet-footed messenger, and Romans cemented Mercury, tying its speed to their trade god. Medieval Islamic astronomers charted its orbit with star charts, marveling at its refusal to linger in any constellation. In Metis 1881, Giovanni Schiaparelli sketched its path, naming craters for artists like Beethoven, weaving art into its scientific story. Mercury's fleeting appearances, visible only at dawn or dusk, made it a celestial tease, challenging observers through the ages. Mercury plays a mighty role despite its size. Its gentle gravity, 38% of Earth's, nudges asteroids and comets, shaping the inner solar system's delicate balance. Its metal-heavy makeup mirrors exoplanets, hot Jupiters and super-Earths, spotted by Tess and Kepler, worlds hugging their stars in fiery orbits, offering clues to how planets form in stellar furnaces. Its eccentric orbit, wobbling under the sun's grip, tested Einstein's relativity in 1919, proving spacetime's curve as light bent near the star. Picture standing on Mercury's edge, the sun a blinding giant overhead, casting sharp shadows on a cratered sea, silent under a star-flecked void. This tiny world, a cosmic anchor, urges us to unravel its tale of endurance, whispering of other metallic orbs gleaming in distant skies. Imagine standing on Mercury's surface, your suit shielding you from a searing 430 degrees Celsius at the sub-solar point, hot enough to melt lead, while shadowed craters plunge to minus 173 degrees, colder than Antarctica's iciest depths. With no blanket of air to trap heat, Mercury's surface is a cosmic oven by day and a freezer by night, its equator roasting under a sun 7 times fiercer than Earth's, while polar craters, locked in eternal chill, never feel sunlight's touch. Your suit would glow red-hot at noon, then frost over in a crater's shadow, a testament to a world of unrelenting extremes. Instead of a true atmosphere, Mercury wears a ghostly veil, thinner than a whisper, woven from sodium, potassium, magnesium, calcium and traces of water vapor, trailing into space like a comet's glowing tail. This exosphere, mapped by NASA's MESSENGER probe in 2011, is a restless dance of particles, constantly ripped away by solar wind's fiery blast and replenished by micrometeorites, surface minerals, and solar wind's hydrogen and helium. Dawn sodium peaks, casting a yellow glow like faint city lights, a 2011 discovery, while calcium spikes at dusk, a rhythm tied to Mercury's eccentric orbit. In 2014, MESSENGER detected water vapor, likely from polar ice or comet dust, a shock for a planet thought scorched barren. These volatiles, more abundant than on the Moon, hint at a dynamic surface, with potassium richer in cooler northern regions, defying models of a fried husk. Mercury's orbit shifts solar wind pressure, boosting sodium emissions at mid-orbit, a 2015 find that paints its tail as a seasonal comet-like shimmer. Yet Mercury's defiance shines in its magnetosphere, a fragile shield, just 1% of Earth's strength, yet fierce enough to deflect solar wind's onslaught in a compressed bubble. A molten iron core squeezed by the sun's tidal pull spins a dynamo, offset 20% from the planet's center, a cosmic quirk MESSENGER mapped in 2012. This field sparks magnetic reconnections, 100 times more frequent than Earth's, unleashing electron bursts with hundreds of thousands of electron volts, concentrated in the northern hemisphere, a 2015 puzzle still unsolved. Picture this shield flickering, charged particles swirling in a plasma storm sculpted by the sun's relentless. Unlike Earth's sprawling magnetosphere, Mercury's hugs the surface, battered by solar wind 10 times stronger, yet it holds firm, a testament to a tiny world's grit. This exosphere and magnetosphere are cosmic laboratories. Mercury's tenuous veil mirrors atmospheres on hot exoplanets like 55 Cancri e, studied by James Webb in 2024, teaching us how worlds retain volatiles near stars. Its magnetic reconnections echo Earth's auroras, but compressed, offering a lab for plasma physics used in fusion research. Water vapor and volatiles hint at chemical processes akin to early Earth, fueling speculation about life's origins in extreme environments, like those on Mars or Europa. Imagine standing under this starlit void, sodium glowing like a distant city, the sun's heat searing your suit, while an invisible magnetic pulse hums around you. Mercury's fiery defiance, glowing in its exosphere and shielded by its magnetic heart, urges us to dream of other worlds thriving in stellar storms. Mercury's surface is a scarred tapestry, a cosmic battlefield etched with craters, lava plains, and enigmatic ridges, glowing under a sun 7 times fiercer than Earth's. Like the Moon, it's pocked with impact scars from the colossal Caloris Basin, 1,150 kilometers wide, dwarfing Earth's continents. Its 2-kilometer-tall rim a frozen wave from a cataclysmic impact, to smaller craters like Radikladi, a younger wound under 1 billion years old, its smooth floor a mirror of cooled lava. Rachmaninoff dazzles with bubbling magma that cracked its surface into crinkled patterns, a 2015 messenger snapshot, while Rustaveli and Copland, their lava-flooded floors glowing orange, whisper of Mercury's fiery youth. These craters, some overlapping like ancient battle scars, tell of relentless bombardment by asteroids and comets, their rims eroding under micrometeorite rain, sharp for newer wounds, softened for older ones. Vast orange-tinged plains like frozen seas stretch across half the planet, evidence of lava flows that drowned ancient craters billions of years ago, forming smooth expanses rivaling Earth's volcanic plateaus. Messenger's 2015 flyovers revealed ash blankets like fiery snow, spewed from vents near craters like Navoy, a 66-kilometer-wide void carved by an explosive eruption, lacking the central peak of impact craters. Some eruptions oozed slow magma, rivers, filling valleys like Angkor Vallis, where lava carved channels like Earth's dried riverbeds, while others blasted ash skyward, coating the terrain in a hellish dusting. These volcanic scars, mapped in 2014, paint Mercury as a world once molten, its surface a canvas of fire and stone. Kilometer-high cliffs, known as scarps, snake hundreds of kilometers. Like jagged scars, proof Mercury shrank as its iron core cooled, crumpling the crust like a drying fruit. Messenger's 2014 data showed a 14-kilometer diameter reduction, far more than expected, with scarps towering over Earth's Grand Canyon, their edges crumbling under micrometeorite rain. Picture these cliffs casting sharp shadows, a testament to a planet squeezing inward, its surface buckling under cosmic pressures. These scarps, some cutting through craters, reveal a shrinking world, a process echoed on cooling moons like Europa. Hollows, Mercury's unique enigma, dot the landscape. Shallow, bright pits scattered like stardust, where volatiles like sulfur or chlorine vaporize under the sun's relentless glare. Discovered by Messenger in 2014, these pits, some mere meters deep, suggest recent geological activity, perhaps within millions of years, making Mercury a living canvas. Unlike lunar craters, hollows lack impact rims, their bright edges gleaming against darker graphite-rich terrain, a contrast Messenger's spectrometers mapped in 2015. These pits, concentrated in sun-baked regions, hint at a surface still shifting, defying its ancient age. Crater rays like Hokusai's stretch thousands of kilometers, their spidery lines, solved in 2018 as rough terrain channeling debris from colossal impacts, wrapping nearly halfway around Mercury's 15,000-kilometer girth. Near Apollodorus crater, the Pantheon fossae forms a fractured glass pattern, like a cosmic spiderweb spanning hundreds of kilometers, possibly from volcanic upwelling or tectonic stress, a 2011 Messenger mystery still debated in 2023 studies. Some propose a deep magma surge cracked the crust, unrelated to Apollodorus's later impact, a puzzle awaiting BepiColombo's sharper gaze. These rays and fractures, glowing against Mercury's charcoal hues, mark a surface shaped by violence and heat. Imagine trekking this scorched terrain, ash crunching underfoot, the sun a blazing giant overhead, casting stark shadows across craters, and cliffs, the silence broken only by the faint hum of solar wind. Mercury's lava plains and scarps mirror early Earth's volcanism and Mars's tectonic scars, offering a window into rocky planet evolution. Its hollows and volatile-rich surface resemble processes on exomoons like Io, studied by Juno in 2024, teaching us how extreme heat drives geology. Volatiles in hollows, like those in comets, hint at chemical precursors to life, sparking questions about habitability in the solar system's infancy. Mercury's surface, a geological diary, whispers of a time when the solar system was a crucible, a fire and stone, urging us to read its scars and dream of other worlds forged in cosmic chaos. Mercury's wild orbit and slow spin paint a bizarre cosmic dance, shaping its fiery days and icy nights, a choreography of gravity and motion unique in our solar system. Racing around the Sun in just 88 days, it traces a wild egg-shaped path, swinging from 46 to 70 million kilometers, closer than any planet, bathing it in a solar blaze 7 times fiercer than Earth's. Canted like a tilted frame, its orbit leans 7 degrees from Earth's plane, aligning rarely for solar transits. When Mercury dances across the Sun's face, only once every 7 years, a cosmic spectacle last seen in 2019, tracked by telescopes worldwide. Ancient astronomers like Ptolemy in 150 CE puzzled over its erratic path, while Kepler's 1609 laws first traced its ellipse, a model Messenger's 2011 orbital data refined with pinpoint precision. Locked in a 3.2 spin-orbit resonance, Mercury performs a cosmic waltz, spinning 3 times on its axis for every 2 orbits, a 59-day sidereal day, unlike Earth's brisk 24 hours. A solar day from sunrise to sunrise stretches 2 Mercurian years, 176 Earth days, making dawn linger for months, a rhythm captured in Messenger's 2011 time-lapses of glowing horizons. At perihelion, when Mercury zips closest to the Sun, its orbital speed outpaces its sluggish spin, making the Sun pause, then crawl backward in the sky for days, a dizzying dance radar confirmed in 1965. Picture standing on Mercury's scorched plane, the Sun a giant orb creeping, then reversing across a sky ablaze. A day stretching 2 years, shadows frozen in craters hiding ancient ice. For centuries, this rhythm baffled observers. In 1889, Giovanni Schiaparelli, peering through early telescopes, thought Mercury was tidally locked, forever showing one face to the Sun, as its 116-day Earth conjunctions always revealed the same side. This misconception fueled sci-fi tales, like Isaac Asimov's 1956 stories of a half-frozen, half-scorched Mercury, until Arecibo's 1965 radar pulses revealed 2 full rotations between views, proving a dynamic spin and rewriting textbooks. From orbit, Mercury spins like a slow ballerina, its poles dark, its equator glowing, a testament to gravity's choreography, its motion a puzzle that took centuries to solve. The Sun's gravitational tug, strongest at perihelion, squeezes Mercury like a cosmic bellows, keeping its iron core molten and sparking volcanism that flooded basins like Caloris with lava, seen in Messenger's 2015 maps. This tidal pull, coupled with a near-zero axial tilt, locks Mercury's poles in eternal shadow, cradling water ice in craters, a 2012 Messenger find estimating 250 kilograms, likely from comet impacts, confirmed by 2023 data reanalysis. The slow spin and tidal stress also stretch the crust, forming subtle fractures, precursors to the kilometer-high scarps Messenger mapped in 2014, signs of a planet sculpted by the Sun's relentless grip. This orbit and spin are cosmic keys. Mercury's tight path and resonance mirror exoplanets like TRAPPIST-1's worlds, locked in similar dances, studied by JWST in 2024, teaching us how stellar proximity shapes geology and atmospheres. Its orbit tweaks asteroid paths, stabilizing the inner planets, a role modeled in 2023 simulations. Polar ice and volcanic remnants suggest chemical processes akin to early Earth, hinting at how water and organics persist in extreme orbits, a clue to life's origins. Mercury's orbital wobble, measured by Messenger in 2011, refines Einstein's relativity, aiding GPS systems and black hole studies. Studying this dance reveals the solar system's delicate balance, urging us to marvel at other planets spinning in stellar light, their days sculpted by gravity's hand. Humanity's quest to know Mercury began millennia ago, when Sumerians tracked its swift path in 3000 BCE. Galileo's 1609 telescope struggled to pierce the sun's glare, but in 1881, Giovanni Schiaparelli mapped its orbit, naming craters for artists like Beethoven. The real leap came in 1974, when Mariner 10's flybys mapped 45% of Mercury's surface, revealing Caloris Basin and scarps. Yet Mercury's proximity to the Sun made orbiting it a daunting challenge. Probes risked accelerating into the star's gravitational well, demanding fuel-heavy braking. In 1985, Chen Wanyan devised a clever path, a 7.9 billion kilometer, 6.5-year journey with flybys of Earth, Venus, and Mercury to slow a probe naturally. Launched in 2004, NASA's Messenger probe followed this route, using solar panels as sails to catch radiation, entering Mercury's orbit in 2011. Over 4 years, it captured 200,000 images, mapping the entire surface, discovering polar ice, hollows, and a dynamic magnetosphere, before crashing in 2015. Recent 2023 reanalysis of Messenger data refined volatile maps, fueling excitement for ESA's BepiColombo, set to orbit in 2025, carrying spectrometers to probe the exosphere and geology. Mercury's elusiveness inspired innovation. Mariner's heat shields shaped Voyager's tech, and Messenger's algorithms aid exoplanet imaging. Its images spark sci-fi like Project Hail Mary, while citizen scientists analyze its craters online. From ancient scribes to BepiColombo's 3,000 builders, Mercury's call drives us to conquer the sun's furnace, urging us to chase its charred beauty and unravel its secrets. Mercury, the sun-scorched sentinel, is a world of searing plains, icy shadows, and a magnetic spirit that defies its size. Its cratered face and fleeting exosphere, glowing under the sun's fierce gaze, remind us how resilient yet fragile our cosmic neighbors are, daring us to explore their extremes. Its ability to endure the sun's relentless fury, cradling ice in darkness and pulsing with a magnetic heartbeat, mirrors our own capacity to find light in hardship. Mercury's story is a cosmic parable, reminding us that even the smallest among us can shine fiercely, bearing scars as badges of survival. As we await BepiColombo's 2025 gaze unveils more secrets, Mercury whispers, could its icy craters or volcanic past hint at life's origins, rewriting our solar story? Mercury's quiet defiance, glowing against the void, stirs a sense of wonder, urging us to explore not just the stars, but the depths of our own courage. Like Mercury, we too can gleam through our trials, our flaws, forging a unique brilliance. Reflect on this. How can we, like Mercury, find strength in our challenges? Let its fiery resilience inspire you to dream big and savor life's fleeting wonders. As BepiColombo's 2025 gaze unveils more secrets, let Mercury's tale fuel your curiosity. Share your dreams of the cosmos in the comments below. Like, share, subscribe and follow our social media linked below. Knowledge is a treasure that never runs dry.